the sound of a car passing by. This distinctive drop in pitch is known as the Doppler effect, and we notice it most with sounds. But it also affects light in the exact same way. If light moved slow enough, we would also see the car change color as it passed us by. The reality is, light moves far too fast for us to notice anything like this. But take a look at this image of galaxy GSZ13. It should look something like this, but its color has been changed all the way to red. In fact, the light from this galaxy has been changed so much that it isn't even visible to the human eye. This is the Doppler effect in action, or, for light, it's known as redshift. Although it may not look like much, this tiny red blob is the most distant thing anyone has ever seen. With this picture, we are looking back 13.6 billion years into the past, when the universe was only 2% of its current age. But the galaxy itself is over 33 billion light-years away. How does this make sense? We know that a light-year is the distance light travels in a year. So if it took the light 13 billion years to reach us, it should be 13 billion light-years away. Well, it's not quite as simple as that. In the time that light has spent traveling towards us, space itself has been constantly expanding, and the galaxy has been moving further away from us. Because of this, the galaxy in 2023 is now over 33 billion light-years away, but its light, from 13 billion light-years away, has only just reached us. But how could we possibly measure this distance? The answer lies within the color of the galaxy. All of the light we see is just a small fraction of the light that actually exists. Every form of light can be thought of as a wave, and the length of that wave can be smaller or longer. This is what determines the colors that we see. But our eyes are very limited, and so there is much more light bouncing around us that we simply can't see. So when we discover a galaxy that has changed color, something must have happened to it. Just like the moving car, the light from this galaxy is being changed or redshifted. But there are two kinds of redshift, Doppler redshift and cosmological redshift. In the Doppler scenario, the galaxy is moving through space. But with cosmological redshift, the galaxy is both moving and stationary at the same time. We'll get to that one later. First, let's imagine the galaxy as if it was stationary. The light leaves the galaxy in every direction at a constant speed. When the galaxy moves through space, the waves at the front get slightly compressed, and the waves at the back get stretched out. Since it's traveling away from us, we are receiving the stretched light, which has a longer wavelength and therefore a different color. But why is the galaxy moving in the first place? The planets in our solar system have movement. Our solar system has movement, and our galaxy itself is also moving through space. But this isn't enough to see a dramatic effect in redshift, since this relative movement is nowhere near the speed of light. But remember that this galaxy has gone from 13 billion light-years to over 33 billion light-years away, a distance only possible if it was going considerably faster than the speed of light. Understanding how this happened is pretty complicated. Since the Big Bang, nearly 14 billion years ago, our universe has been constantly expanding. But understanding what this actually means is pretty difficult. We imagine the Big Bang as an explosion that radiates out from a central point. But in reality, there is no center of the universe, and no single point where space expands from. If you take any point in the universe, everything will appear to be expanding away from it at the same rate. It's not that planets, stars, or galaxies are getting bigger, but the space between those galaxies is getting bigger. The rate of this expansion is around 70 kilometers per second for every 3 million light-years of distance. So an object at that distance will be 70 kilometers further away after a second. An object 3 million light-years further down the line will be 140 kilometers further away, and so on. If we extrapolate that out to galaxy GSZ13, it will be moving away from us at around 700,000 kilometers per second. But we're told that objects can't move faster than the speed of light. But that is only true for objects moving through space. This is where cosmological redshift comes in. If we look at an unbaked cookie, we have a random scattering of chocolate chips, which we can think of as galaxies. When the cookie gets baked, the dough expands, and the chips end up further away from each other. But it's not that the chips have moved relative to the dough, but the dough in between the chips has expanded, just like our universe. The galaxies in our universe can't move through space faster than the speed of light, but there is no limit to how fast the universe can expand. This means that the light currently being emitted from this galaxy will never reach us, since the expansion of the universe at this distance is outracing the speed of light.